So this is problem number 51, your last problem that you need a calculator for. So it states that the exponential growth is modeled by the following function given over here. And we know that a culture contains 500 bacteria when t is equal to 0, and after 1 hour the number of bacteria is 1200. So we know this, and this is important information that is given to us. So if we know that t is equal to 0, right, then really e to the power of 0, that's just 1. And so we know that n here, this value over here, right, n naught over here, that must equal 500, right? Because when t is equal to 0, e to the power of 0, that's 1, right? Therefore, 500 must equal n naught over here. So that's pretty obvious, and we know this. Now, how does the second information play into this problem? It states that after 1 hour, the number of bacteria is 1200. So you can use this equation. You know that 1200, well, you already know what n naught is. That's 500, right? That's 500, and you know it's going to be e to the power of k times, well, it's 1 hour that we're talking about, so it's k times 1, or that's just k, so it's just 500 times e to the power of k. And thinking about this further, we have all the given information that we need to determine the value of the constant k. So dividing both sides by 500, we get 12 over 5 is equal to e to the power of k. Well, you think about this, that's saying that ln of 12 over 5 is equal to k, right? Because again, ln is log base e of 12 over 5 is equal to this exponent, which is k. And so you can evaluate this in your calculator, and you should get that k is equal to 0.875, rounded to 3 decimal places. So this is the value of k, 0.875. Now part A here states that how many bacteria are there after 4 hours. So you want to know the number of bacteria after 4 hours. Well, you know the value of n naught and you know the value of k, right? So really, after 4 hours, you are going to say that n is equal to, n naught is 500, times e to the power of, well, you know k is 0.875 and your t is 4, so e to the power of 4 times 0.875, right? So this is your value for n here. And so when you calculate this value, you see that n is equal to 16,558. So we get the value of n is equal to 16,558. Again, it's more of an approximation. If you're under your value here, you are not exactly the value here. You may see a fluctuation of something like 100, but your answer lies somewhere here. So 16,558. Now we have part B, and part B here states that after how many hours will there be 8,000 bacteria? So let me just erase this here. So we have part B now, and our part B here states that after how many hours will there be 8,000 bacteria. And so for this problem, it's again quite simple. We're just substituting the values we know for constants and for what's given to us. 8,000 is what we place in for n. We know that n naught over here is 500, right? That we derived that from this information that was given to us, and then we know times e to the power of k times t. Well, k is obviously 0.875. We did determine the value of k as we use this information over here, that after 1 hour the number of bacteria is 1200. So we know that k is 0.875, and then we want to find t because we're looking for the number of hours that will take for 8,000 bacteria to exist, right? So that's what we're looking for. We're trying to find t here. So this is the equation we have. And now what we're doing is we are going to divide both sides by 500, right? So you see that 16, right? 16 is equal to e to the power of x. And I'm just saying x. We can say that x is equal to 0.875t, right? We can just assume, or we can let x is equal to 0.875t. So we know that x is equal to this this exponent over here, right? So 16 is equal to e to the power of x, and therefore ln of 16 is equal to x. So we know that the value of x is 2.773 right after we calculate this in our calculator, right? So we see that x is equal to 2.773, and we know that the value over here, right, this value of x is equal to 0.875t, right? Therefore t must equal 2.773 divided by 0.875. That's the value of t, and so you should see that the number of hours is approximately 3.169. 3.169. So after how many hours will there be 8,000 bacteria? Your answer should be 3.169 hours, or something like 3.17 hours. Those are prompts, or those are parts A and B, right, that I've answered here for question number 51. And so in the following lesson, I will be going over questions 52 to 57 that incorporate one graph, and now we will be looking more towards limits, right? The concept of limits, which is fundamental for calculus. So thanks for watching.